Our first session is Introduction to Exadata, where we'll be exploring why Exadata is so much more than just hardware. We'll take a high-level look at the magic that makes Exadata unique and the intelligence that's built into it. For example, Exadata internally uses strategies such as data warehousing, real-time decision-making, and artificial intelligence in ways that solve database performance and capacity issues, something that's just not possible on traditional do-it-yourself hardware architectures. Our speakers for this session are Dipanshu Agarwal, based in sunny California, Santa Clara to be exact, and Cyril Maliki, who's over on the East Coast in Reston, Virginia.
Hello, and welcome to a session on Introduction to Exadata. We will take you through all the features of the Exadata, which makes it the best platform to run the Oracle database.
What is Exadata? It is an engineered system. There is co-engineering inside each layer. There is co-engineering between layers. That means Oracle Enterprise Manager can be used to drill down from top to bottom or bottom top. You can see alerts from application till the storage layer using Enterprise Manager itself. And it is really easy to integrate these systems with other systems too.
The Oracle Engineered Systems family consists of multiple platforms for different use cases. The Exadata is the best platform to run your Oracle database. On the right side, the ODA is an entry-level, simple, highly available database appliance for much smaller Oracle workloads. The PCA is the virtualized platform for the Engineered Systems family. It is an agile and intelligent infrastructure designed for rapid and automated deployment of private cloud and cloud-native applications in your own data center. ZFS and ZDLRA, on the other end, are the data protection platform from Oracle. ZDLRA is a cloud-scale, optimized engineered systems for Oracle database backups. As the name suggests, it guarantees zero data loss for backup and recovery. ZFS is the Swiss Army knife of engineered systems. It can provision storage via multiple storage protocols like iSCSI, NFS, and Object Store. One of the largest and the best use case for ZFS is to host your RDMA backups from an Exadata. Exadata has been a game changer for hosting Oracle databases since the V1 version was released in 2008. The latest generation of Exadata, the X8M, introduced in late 2019, is the 10th generation of Exadata and is also the best and the fastest released Exadata to date. It is a powerful combination of state-of-the-art hardware and the latest Exadata storage software. Exadata has introduced many industry-leading and differentiating technologies like SmartScan, Elastic Flash Cache, hybrid columnar compression, storage indexes, and IORM over the last 10 years. X8M, the latest Exadata, introduces persistent memory and RDMA over converged Ethernet for the first time in an Exadata environment. These newly added features, along with other consistent Exadata features, makes it not only the best platform for Oracle database, but also helps beat its own predecessor, the X8, by a whopping 250% in overall performance. The Exadata hardware is fully redundant without any single point of failure. The Exadata rack depicted on the left consists of compute servers in the red box, which hosts the database. The RoCE network switches are depicted in green, which serves as an interconnect between the compute and storage servers at 100 Gbps. The storage servers are depicted in blue. A single compute server, which hosts the database instances, consists of two 24-core CPUs and 384 GB of DDR4 RAM. The DRAM can be extended all the way up to 1.5 terabytes per compute server. The compute server also consists of either the 10 GB or 25 GB external network which connects into your core switches. This network serves all the applications connecting to the database instance. The RoCE switch, as we mentioned, in green is the 100 Gbps throughput between compute and storage cells, with RDMA capability for super fast data transportation between the compute and database servers. The storage cells in blue is contained within the Exadata rack. There is no additional need to purchase storage from a third-party vendor. Each of the storage server also consists of 32 cores of processing power for SQL offloading. The CPUs of the storage server does not require a database license while it handles all the offloaded queries. This helps to consolidate the number of database licenses required on the compute server when moving workloads from non-Exadata environment to an Exadata environment, resulting in dollar savings. The storage server also consists of 1.5 terabyte of PMEM in each of them, along with NVMe flash and hard disks. There are basically 3 types of storage servers available based on the use cases. This slide depicts the 3 different types of storage servers: the extreme flash, the high capacity, and the extended storage. The extreme flash storage server consists of 8 6.4 terabyte of NVMe flash cards, along with 1.5 terabyte of persistent memory. The storage server also comes with 192 GB of DRAM. The high capacity server, on the other hand, has DRAM and PMEM same as the extreme flash storage, while the flash is cut in half, basically having 4 cards of 6.4 terabyte each. It is also front-ended with 12 14 terabyte high capacity disks for data. The extended storage, on the other hand, consists of just one 16-core CPU, 192 GB of RAM, and 12 14 terabyte hard disks. They do not consist either of PMEM or flash cards.
So Cyril, what is the use case for these extended servers, XT?
Good question, Dipanshu. XT, or the extended storage, is mainly used to store infrequently accessed older or compliance and regulatory data. You can also use it to store some things like contracts, blobs on the extended storage. Some customers also have requirements for internal backups, have found great use case with XT storage. We also have some customers running their development databases out of extended storage as well.
Thank you.
The Exadata, as we saw, is an extremely highly redundant system, but they are also scalable, which is very important in this fast-growing world. The smallest Exadata system that can be purchased is an 8th rack Exadata. An 8th rack consists of 2 compute servers and 3 storage servers, both half populated with CPU, flash, and disks. A quarter rack, on the other hand, is the next increment with the same 2 DB and 3 storage servers, but all the components are fully populated. Exadata can then be configured or grown either in half and full rack configurations or as an elastic rack. The elastic rack can have any combination of compute and storage servers, totaling up to 22 nodes per rack. If, for some reason, a customer requires greater than what can fit in a rack, Oracle also provides the opportunity to multi-rack Exadata systems. You can grow the Exadata up to 18 rack in a single unified cluster, making it a humongous cluster. Each full rack Exadata, which consists of 8 compute and 14 storage nodes, usually comes with about 800 terabytes of usable data store. On the right-hand side, we can see the X8M. So what is that? The Exadata we spoke up to now is the X8M2. The X8M8 is nothing but an 8-socket SMP Exadata offering. They're used mainly on extremely high compute application requirements. They An Exadata X8M rack comes with 2 compute nodes, each consisting of 8 CPUs of 24 cores, totaling a whopping 192 cores per server. They also come with a default of 3 terabyte of DRAM, which can be extended all the way up to 6 terabyte per compute node.
Thank you, Cyril. Now that Cyril has covered about the hardware, let's dig deeper into what comes in software. On the storage server, there is storage software installed. In this image, on your left-hand side, you have database features, and on the right, you have Exadata features. These Exadata features are the software features which help achieve the best performance for the Oracle database. One quick note, for Oracle database feature, Advanced Analytics, Spatial and Graph feature is now available with Enterprise Edition at no extra cost. Let's dig deeper into the smart scans. We all spoke about offload. There is something which Exadata does, that is offload of SQL queries to the storage server. How does it do that? Let's take a simple example. We have a select statement where select customer name from calls where customer amount more than 200. What happens in this query is when it reaches the storage server, storage uses predicate filtering and columnar projections to reduce the amount of data pulled out. It is going to remove all the columns which do not match amount greater than 200. Then it is just going to use those columns, which is customer underscore name, and send that small amount of data back to the database server for processing. This helps us reduce the amount a lot. We are not bringing the whole table back. We are bringing very small chunk of relevant data back. You can use Smart Scan to offload in database analytics, machine learning algorithms, decryptions, decompressions, and backups too. Parallel execution of OLTP updates happens because of Smart Scan. Oracle database only licenses database server CPUs and not storage server CPUs. This helps you save on licensing too. Storage indexes. Storage indexes play a very crucial role in offloading. Storage indexes are nothing but in-memory dynamic indexes which are created in storage cells. They hold information about a region of 1 MB of disk space. They have a minimum and a maximum value. In this query, select star from census data where age is less than 35. Traditional database would bring the whole table back to the buffer cache. Let's say my table is 35 GB. Whole 35 GB of the table will be coming back to my database buffer cache. In Exadata, it will only bring the data which is required to satisfy the query. Storage index helps to eliminate the need of do any extra physical IOs on the disk that will not contain the data. In this query, a pictorial example, on the right-hand side top, I have my storage index. The middle section where age, minimum value 47 and maximum value 88 will not satisfy my condition. So the whole region attached to that storage index will get skipped and I save on IO. Another feature is hybrid columnar compression or HCC. We all know about advanced columnar compression which Oracle provides as a database feature. This is Exadata specific feature. When in a relational database, we save our data in row format. That is, for a single row, all the column data is saved together. Another way to save data is column format, which can give you really high compression rates because I have the same data type and characteristic of the column. Hybrid columnar compression or HCC on Exadata uses the best of both worlds. It uses columnar data for compression, but somehow not getting the performance degradation in columnar formats. There are two modes you can run HCC in. First is warehouse, which can be used for read-intensive workloads. And second one is archive, which provides the highest up to 50x compression, should be used for read-only workload, which has to be there for compliance purposes only. That data can be used to move on XT as well to save on storage. IORM. IORM is part of resource manager, which is a bigger topic, which includes CPU, instance caging. There is DBRM, that is database resource manager, and then IORM. Instance caging is a way to limit the amount of CPU required by a process. We all know that any process running on the system either needs CPU, memory, and I/O on the hard disk. DBRM, which has been there from quite some time, can be used to choose the amount of resources or restrict the amount of resources required in a single database given to a process or a schema or a user. IORM, on the other hand, helps you to control the share of I/O given to different databases. In this example, we have two databases, production and development. On production database, I have ad hoc query running and I have my critical reports, which I care most about. On development, I have reports running. If you see, the total amount of bandwidth available is 1200, but the actual bandwidth is 2200. Now, I do not want my critical reports to lag because of not available bandwidth. This is where IORM comes in picture. I can use IORM to manage how multiple workload or and databases share the available bandwidth. So I can give high priority or more shares to my critical report to make sure this will run faster than anything else on the system. Another feature is Columnar flash cache on Exadata. Hybrid Columnar compression, which is HCC, balances need for both OLTP and analytics. As CPU gets faster, it is looking for faster scans. Smart Flash Cache automatically transfer blocks from HCC to pure columnar format and save them in Flash Cache. Whenever I am going to do scans on column data, it is going to read faster and it is going to save CPUs, which can be used later for other storage indexes too. Unique fault tolerant in-memory database. In-memory database on any other system is basically my whole database is sitting in the RAM. In this scenario, when a database server crashes, it will take a lot of time for data to get repopulated on the other database node. Exadata solves this problem too. It uniquely duplicates the data in memory to another server, similar to the storage mirroring. This eliminates the downtime and it automatically switches to the duplicate copy after the failure.
Hey, Sudhanshu, thanks for this introduction to all the Exadata features. I have a question over here. So what inhibits me from doing all these things that you spoke about, the smart scans, the IRMs, on, say, a DIY cluster that I would just implement myself by buying some third-party storage and Intel servers?
Good question, Cyril. So if you see, it is easy to buy hardware and put it together, but it's all about software. First thing, if you see on Exadata, we own the whole stack. So be it Oracle Enterprise, Linux running on database server, or be it storage server, every one of them have trust in each other, because of which we can bypass whatever we want. Second thing, all this software, Oracle has taken 12 years to perfect them. When you even put a DIY system, there is no way you can replicate the software and get the same amount of performance, which we can get from Exadata.
Awesome. Thanks, Dipanshu, for that explanation. So I spoke about two technologies that were introduced in the X8M a little earlier. They are the RDMA or the RoCE and PMEM. So let's first understand what RDMA is. The diagram over here depicts how RDMA process works. The RDMA protocol has the ability for one computer to access data from a remote computer without any operating system or CPU involvement. Network card from one system directly reads or writes the memory with no extra copying or buffering at a very low latency from the second system. In this case, this can be used to read data from the storage server from the compute server. So the compute server uses RDMA to read and write data from the storage server's memory region at the network card level without using the operating system or the CPU overhead. This has been in Exadata from the very beginning. However, in this generation of Exadata, we are deploying it on RoCE. RoCE stands for RDMA over Converged Ethernet. RoCE provides RDMA speed and reliability on Ethernet fabric. Exadata implements RoCE at 100 Gbps speeds, providing zero packet loss and network prioritization for critical database messages, all within the Exadata storage software algorithm. RDMA has been an integral part of Exadata high-performance architecture. RoCE now allows high throughput and low CPU usage for large data transfers. Direct-to-wire protocol enabling 3x faster internode OLTP cluster messaging. It also enables smart fusion block transfer at higher speeds. RDMA helps coordinate transactions between different database nodes. The second technology we spoke about being introduced in the X8M is the PMEM. PMEM is a new silicon technology to store data persistently at near memory speeds, but at a lower cost. Exadata uses Intel Optane DC persistent memory PCIe cards, which provides read at memory speed and writes which survive a power failure at much faster speeds than the flash cards that have been part of Exadata. Exadata uses sophisticated algorithm within the Exadata storage software to maintain data integrity on PMEM and provides RDMA to access the PMEM in the storage cells. We spoke about RDMA in the previous slide. So now here we see how RDMA accesses the PMEM data from the storage server, in the storage server. Next. By integrating PMEM and RDMA in a shared storage architecture, Exadata provides some unique advantages over our competition. Exadata utilizes PMEM capacity by only moving the hottest data into the PMEM. This is achieved autonomously by the Exadata storage software without any input from the user. PMEM is also only accessible by RDMA. It is not accessible by the operating system on the compute server, making it extremely secure because no other user will be able to access the data. PMEM implementation is made extremely resilient as well by mirroring the PMEM modules across the storage servers. Now let's look at what we learned today with a traffic jam analogy. To begin with, let's see where actually a bottleneck happens in a regular DB system. When you look at a regular database architecture, it consists of compute nodes, SAN connectivity into your storage fabric. So some of the best SAN available today provides you with 40 Gbps SAN link, which translates to about 5 gigabytes per second throughput. However, most of the storage subsystems that come today are NVMe flash based, and they have read and write speeds of about 5.8 gigabytes per second. So as you can see here, a single NVMe flash card can throttle an entire SAN link. Now, if the storage subsystem has hundreds of thousands of flash cards, trying to write or move the data to the compute server into your SGA, there is a bottleneck at the SAN fabric layer. Exadata solves this by implementing multitudes of technologies that we spoke about. Let's analyze it with a traffic jam analogy. Let's depict this here. We have people trying to get from point A to point B in a few lanes with lower speed limit. This depicts a generic DIY implementation of computer and storage servers. However, in Exadata, we introduce smart scale out of storage. And as you can see now, the number of lanes have increased. This now enables more people to move over the additional network lanes. We also enable the capability for the compute to look at the storage in parallel fashion by configuring the storage server in a cohesive grid. This enables the compute to see more data at the same time. Though we increase the number of lanes, As you can see, we still have a lower speed limit. So we then provided Exadata with a faster road to travel via the 100 Gbps converged Ethernet switch. Now, the same data, or cards here, have multiple lanes to travel through at much higher speed limit, thanks to the converged Ethernet fabric. Okay, so now we have more channels and faster speed. Great, but we still have a lot of people moving through the lanes. We use hybrid columnar compression now to fit more people into lesser cars. This reduces the number of cars that are required to be traveling on a lane. So now we have increased the number of lanes, increased the speed limit, and put more people in a single car. What else can we do? Can we reduce the number of cars that needs to be out there? Yes, we can. We moved the SQL queries over to the storage servers and perform some of the compute activity on the storage server CPUs and bring back only the relevant data back to the compute servers. By doing this, we further reduce the number of cars that's needed out there on the highway. That's your smart scan. This makes it really good, ain't it? Next, we also prioritize traffic. The Exadata storage software can distinguish between different types of traffic, whether it's OLTP or OLAP. The prioritized traffic takes the prioritized lane. IORM helps you prioritize traffic over prioritized lanes. Again, this is done by the Exadata storage software for you. You do not have to need to do anything on your end. Now, with the X8M, by introducing RDMA over RoCE, we further reduce the overhead. Usually, for your data to move from point A to point B, you still need to traverse the entire network. With RoCE, we reduce the total path that the data needs to travel. It does not have to traverse the entire length of point A to point B via the CPU, networking, memory, etc. on the compute node to that on the storage node. But now, because of RoCE being implemented in Exadata, the data gets to travel directly from point A to point B on the network card, thereby reducing the amount of travel required.
Thank you, Cyril. One more question I had was, as you mentioned that RoCE can help you move data from point A to point B. Will it be applicable when I'm talking from one database node to other database node? That is like cache fusion.
Yep, absolutely. So cache fusion is also helped tremendously by the implementation of RoCE.
That is great. That means we can reduce our GC wait events a lot.
That is correct.
So moving forward, these are 60 Exadata only features which are available on Exadata. These are Oracle features. They are divided into availability, security, performance, scalability, and efficiency. Exadata X8M IO with all flash EMC. If you see, latency is 5x lower for Exadata. OLTP reads is 2x more for the number of IOPS we get from Exadata, that is 16 million. X8M comparison to flash block storage on AWS or Azure. From AWS, we have 50x lower IO latency. From Azure, we have 100x lower IO latencies. Exadata X8M benefits. OLTP workload benefits. Latency is less than 19 microseconds, 16 million IOPS, and super fast log writes, only for OLTP workloads. This makes it really fast. For data warehouse or mixed workloads, we have PMM with RDMA, which frees up CPU on the storage to do more smart scans. RoCE is 100 gig, which can help you increase the throughput really high. The big picture is Exadata was really fast because of optimized flash. Now because of PMEM, we have brought really low latency too. New class of applications like IoTs, AI, ML, all those workloads and algos get offloaded as well with smart scans. And no application changes are required to achieve this. Exadata advantages. This slide shows the dedication Oracle has towards Exadata. Every year in smart hardware or software, new features have been added to make sure this remains on top of every platform out there to run Oracle database. Latest was Autonomous Database, and on hardware side was RoCE. Thank you for tuning in. Have a good day.
Thanks, Cyril and Dipanshu. That was a great introduction to Exadata. It's interesting to consider how many fewer cores you need when you run a platform designed specifically for the Oracle database that leverages all the features that have been introduced over the years.